Good morning, all. Sorry for the delay in starting the meeting.
Good morning.
Yeah,
good morning.
My sincere apologies. Engineer Uche had some technical issues starting up the meeting, but thankfully it has been resolved and we are good to go. So I'm going to drop a message on the WhatsApp for those of you that are still, or for those of us that are still finding it difficult to connect, so that everyone gets connected.
So good morning, everyone. My sincere apology for one technical issue I had this morning.
Good morning, sir.
Thank you so much for your patience. Thank you so much for just hanging on there till you were able to be admitted.
No,
Inachima. Hello.
I'm here, Engineer Uche, I'm here.
Okay, I hope you're not having technical problems. I'm seeing your name multiple.
Yeah, I don't know why it's doing. I don't know why I'm having so multiple names here.
Even last time, I think I saw the same thing.
I really don't know why.
Okay. Thank you for participants and all our resource persons. Some of our resource persons are already on board. I can see Engineer Chimobi. I can see Engineer Maduko. Today is the final day of this training. And in the last 4 weeks, we have really had a good time. So today we're going to cap it up. Just to wait for others to come in. I think we are 21 already, maybe a couple of people. Can we get a sort of feedback in 4 minutes about our technical visit?
Engineer, sorry, just to be sure that I don't know why my name is appearing several times. Can you please take away the one that the ones who the mics are muted? My mic is on, but for every other Chimamoneke whose mic is muted, can you please take them away?
Inashima, the challenge is that if I remove you, I might you might find difficulty coming back.
No, what I'm saying, because it's appearing multiple times. I see my name like 3 times.
I'm removing now.
So the ones whose mic is muted, you can just take those ones away.
There are 3 Chima Moneke, so he needs to remove 2. Hello, yes. He needs to remove 2. There are 2 others apart from the one from which you're speaking.
Yes, so the other 2 should be removed. I don't know why
he needs to remove them.
Well, if that's a challenge for you, Engineer, maybe we should just ignore it and continue, so don't waste so much time on this. Or you can also make me the co-host so that I can handle that from here while you continue.
I think the host has been moved to Namdi somebody.
Oh, Engineer has somehow gone out from the meeting.
Yeah, the host automatically moved to Namdi, but I can't even see Namdi here. I don't see who Namdi is. I hope he's not gone too.
I don't know why this is happening.
Namdi Kweze is new host.
It's not the host, right?
Yeah,
okay.
Maybe even Namdi can hear us. He should make Engineer Chima the co-host or host, whatever, so that we solve this problem.
Namdi, I don't understand though.
They've made you the host.
Why?
Yeah, okay,
I'm a participant.
I think engineer
Yes, now. Okay, so today I want to take us through mini grid design, just an overview.
Please go to the presentation mode so it can be fully.
At the bottom.
Okay, so I would like to take us through mini grid design, just an overview. First and foremost, in everything we do about mini grid design, we should always remember that it is engineering design. And so whatever applies to all other engineering designs apply in mini grid design. So we follow the everyday principles. And in following the everyday principles in mini grid design, we should always remember these 4 basic considerations. The first one we always have to consider is safety and security considerations. Next one is economic and socio-political considerations. We have functionality, is it functional? And then finally, we have aesthetics. When it comes to safety considerations, we always have to know that the environment have to be safe. For example, in planning your layout, you don't have to put your solar PV panels where they will obstruct the road. The local government will just simply tell you to remove them. In planning your mini grid, when you are planning your distribution lines, you should also know that the poles should not fail, or you should, in fact, your environment have to be safe. You don't have to constitute nuisance, getting electric shock for people. So you just have to know that everything has to be safe for the people in that environment. If not, NESRA will shut you down. Then next thing is people who are going to implement the project. You will need your site inspection. Are you going to put your solar panels on 5-story building? You that is designing will have to know all these considerations. So you have to be aware of your environment so that as you are planning, as you are designing, you are also planning for necessary tools, necessary equipment to install, necessary safety devices for people who will operate the system to do that. For example, if you are designing a mini grid and you are getting up to 500 volts, 1000 volts, you should know that the system should be able to withstand such a high voltage. So it has to be safe for people who are going to operate it. The consumers don't have to get electric shock, and the equipment themselves, you don't have to design things that somebody will just come and cut it away. If you are going to install battery and battery cabinets, from your design, you must make sure that it is fast fixed such that thieves will not just come, carry everything and go. So you are also designing for safety of the equipment, the security. You are designing to protect the revenue. You don't have to finish designing your mini grid, and when you come back, you say, oh, there is energy theft. You think all these things from the word starts. So if you ignore the safety provisions, then you are going to meet the consequences. Part of the consequences is that the regulatory agencies can just come and shut you down. Number one, we have in NESIS, we have, this organization headed by Engineer Peter Onwal, I've forgotten their name again just at the moment, but if I remember their name, I'll just mention. So even Koren can come and shut you down. NESRA can come and shut you down once you fail to comply to the regulatory rules of safety, because that's like a very important area, safety of all the people. That's what almost every regulatory agency will like to focus on. So if you also fail to meet safety and security considerations appropriately, let me say, the project owners can simply turn it down. After designing everything and building it, maybe the client will say, no, I don't accept this. So it's part of the risk you are going to face. You also have like, if you don't consider the safety and security considerations very well, I don't know if you will be proud to say, I designed a mini grid that killed how many people, maybe from electrocution, or it just rained. Maybe one wire slipped or fell in the damp ground, electrocuted all the animals. These are the kind of things that will happen if you don't take your safety and security considerations appropriately. So where will you find the safety tips? From standard books, we have our NESIS, Nigerian Electricity Supply Industry Standards, that's NESIS, IEC, International Technical Commission, IEE, and so on. When you are designing for Nigeria, the first standard publication you have to focus on is NESIS. Where the standard provisions are not in NESIS, you can now choose IEC. This is because NESIS is the Nigerian national one, more like our constitution. So if there's anything conflicting between NESIS and IEC, NESIS will take dominance. So that's why NESIS is number one. Then every other one choose behind NESIS. Even though we know that in preparing NESIS, they also made reference to the international ones like IEC, IEEE, and so on. So apart from getting your safety tips and safety considerations from the standard books, you can also from the previous lessons learned, because every day, I must say the truth, the standard books may not contain all things that may likely happen. That's why we have accidents, because they are unexpected. So from lessons learned previously from previous projects, you can always make provisions. For example, you may not see theft extensively in NESIS, but from previous experience, you can say, okay, this is what we need to do to prevent energy theft, equipment theft, and so on. So you just have to make reference to previous projects if you have any, and then your common sense too. Sometimes, if you're designing, you know that your equipment don't have to be like in a place that, let me say, if it gets flooded and people just want a sidewalk, they will be touching it, especially if it's high voltage. Common sense will tell you like, just, yes, I know like this particular point is still within my equipment yard, but at any slightest thing, somebody can touch it. No, let me keep it away. So your common sense will also help you to do this. Then we have economic and social considerations. Before you start designing your mini grid, first and foremost, you have to consider, why are we doing this project? Is it for economic reasons? Sorry, let me say for profit making venture? Is it for, let me say, socio-political objective, like one senator just want to do a project so that people will clap for him? The considerations you make for these scenarios are quite different. So if it is a case where somebody just want to make projects so that, okay, we call it legacy projects. That's what they call it in Nigeria. So that people will say, ah, the senator just did this particular thing for us, everybody clap for him. You may not need to bother about how long it takes for the projects to pay back. Maybe the tariff will be low. Maybe if the project is going to be collecting revenue, it will just be to ensure that the project, the grid is maintained and continue supplying and so on. So maybe you will not have to pay attention to devices that will ensure revenue protection, and that will save you costs. Maybe, so if you're going to design for commercial purpose, like it's going to be profit making, that says that from the word start, when you are designing, you also have to think about revenue protection. Are we going to install meters? Are we not going to install meters? You have to think of all of them. So Examples of another most important thing is that as you are designing for commercial purposes, you want to make profit. You have to make sure that you understand, number one, the prospective consumers very, very well. And this is particularly one mistake I know that several companies that have tried implementing mini grid, this is what they don't often do fine, because some people will just start designing whatever you think, you just do without realizing that you have to check, number one, the energy consumption needs and pattern of the people you are designing for. You have to check their average earnings and payment ability. You have to check their willingness to pay. You have to check whether they are even willing to protect the equipment installed in their environment, or whether they are going to tamper and vandalize it. You have to check their willingness to render non-money related services. For example, if somebody sees that the pole is bending and maybe may likely fall, will that person pick his phone and call, hello, my utility company, there seems to be a problem here, come and check. These are non-money related support that people can give. Are they very hospitable? Will they host you, or will they be hostile? I'm sorry for people that have tried walking around Wari region. You know that you dare not dig a ground without paying huge money for community, whatever. So these are the things you have to consider as you are designing. And all these things influences your design choice. For example, in a place where, in a community where they are not earning so much and they are willing to pay, you may not have any need to install meters for them, because meters may add up to the cost. Okay, let me not say meters, maybe smart meters. You may not need to. You may just need to say, okay, let me install a very simple and cost-effective meter. Since they are willing to pay, they will just, anytime you come, you read off what is in the meter and bill them, if you want to use that as a business model. If it's a community that are willing to pay and their energy consumption is not very high, you can be like, okay, since it is just few bulbs, let me say in very remote areas and they use it in the night, maybe they can just be paying 100 naira and they are okay. Like, it will make you to say, okay, I will shed off some of these equipment required to make the mini grid successful, and then the thing will still be successful. If it is a community that steals so much, vandalizes so much, part of your design will include things that will protect your equipment. For example, you may need to use heavy iron, guard your inverters, guard the region of your panels, put in CCTV to look at it if need be, perhaps put electric fence. And the fact is that the more you put equipment in your mini grid design, the more the cost increases. And also, the more you just keep adding equipment to your mini grid design, the more the cost increases. And also, that's the more the levelized cost of energy also increases. That's your tariff. So if you just sit down and you didn't make extra efforts to understand who your consumers will be, you may end up designing a very costly system for them. When you now tell them, this is your tariff, they'll be like, it's too high. I'd rather burn my kerosene lamps. Or they'll be like, I had rather I pass my neighbor any day I want, I'll just buy fuel instead of paying this amount. So it's actually very important. Then we shouldn't also forget that if you design something that is very, very costly, it will be difficult for the financiers to bring out the money to finance it immediately without having, should I say second thoughts? Maybe up to 10 thoughts about it. All of us know that it's easier for somebody to spend 10,000 naira than to spend 100,000 naira. If anybody accustomed you now, like, please, I need 10,000 naira urgently, you may not even think it twice. You just be like, okay, no problem, you give. But that can never be the same case when somebody is asking you to bring out 500,000 naira instantly, will be like, the first question would be like, what for? Like, how will I get it back? So the same thing applies to designs. If you design, the higher the cost, the more you add things. Like if you, instead of using simple electronic meter, if you are using smart meter that is costing you, let me say up to $100 per unit, your financiers will also find it like more challenging to raise that $100. But if you're using a simple electronic meter that is like $10, $15, $20 per unit, maybe it will be far easier to fund the project. So much as engineers may not own the full responsibility of building the energy business model or coming out with commercial operation strategies, one thing is very sure: they cannot just work in isolation. If we want the entire mini grid design to be successful in the future, it has to be like a multidisciplinary team. Maybe they have to understand the commercials starting from the time they are installing, and this will help them to make some key decisions. And those key decisions, example of them is choice of OEMs. Most often people will be like, okay, what is the most popular equipment in the market? Let me say, I know that one of the popular equipment in Nigerian market is Victron, inverters, and so on. Maybe if you come to solar panels, Canadian Solar, Jinko Solar, and so on. But are they the best? I cannot simply tell you yes, because for an average engineer, we have criteria how we know what we want. We simply refer to data sheets of Victron and other products in the market, and then make a decision. Like after going through, you will ask for like, okay, where's the warranty? Where's the product certificates? I mean, things that will convince you that, yes, these people, what they are stating here, they can actually, in fact, sometimes you will like, okay, can we see sample? Can we see test reports? So being an engineer, a power system engineer, I know that, in fact, I can tell you categorically, country of origin does not matter. I know that Nigerians have this notion that if it is a China inverter, no, it's fake. Or if it's Indian inverter, no. But the truth is that even the ones you thought are manufactured in US or Europe, if you check carefully, they are manufactured in China for people in Europe. Example includes this Victron. The owners are not Chinese, but manufactured in China, even your Apple phone. So when you are making the choice of OEMs, it's not actually like a question of the most popular, but then you just have to, as an engineer, to look at your spec sheets, make your decisions. So other areas engineers have to make serious choice will be like choice of materials. When you are doing your mini grid design, after evaluating your customers to know that I don't have to do something that they cannot pay for, then you will now decide in your distribution lines, should I use concrete or wooden posts? You will decide, because you must design what your customers can easily pay for. Should you use copper or aluminum cables? People will tell you, copper is the best. But as an engineer, we all know that we design based on unique conditions. That's what makes us engineers. There are some places that, yes, copper will work, but aluminum will also work. Which one is more cost effective? You choose. You decide, like I said, am I using smart meter or just an energy meter? Digital or analog is a choice you have to make. Choice of technology, am I going to use overhead cable or am I going to start burying underground cable? I know I have once told someone that the person is just saying that he has done a wonderful design for Kaduna State, and they are going to bury all cables underground. Like they are going to give, when I ask the person, are you thinking of maintenance? Are you thinking of the initial cost? Because normally people that are making the choice of overhead cables are making that choice because it's cost effective. But then if the person, because let me say there's a grant or the financier can easily finance now, and the person make a design of underground cable for a place that cannot pay the cost of this underground cable now and in future, you see that that's already a bad design. Initially, it may look good, but when the thing cannot realize any revenue and they cannot, and the financiers cannot keep on bringing money for maintenance and paying staff, you will see that everything will start deteriorating. The choice of revenue protection schemes. Are you going to, when it comes to energy theft, you know that if bad conductors are just crossing people's premises, they can just hook their wire and tap the energy. Do you want that? If you don't want that, you can use insulated cables. If you're using insulated cables, it's going to add a little bit of extra margin in your overall design cost. Do you want that? That's a decision you have to make. And all of them are embedded in your designs. So normally an average person may think that revenue protection is a question of commercial department, but it also involves engineer, because it's the engineer that will have to make sure that apart from the revenue protection policies, when it comes to the technological aspect of revenue protection, it's embedded in the design from the onset. Supply capacity and duration. As you are looking at the consumption pattern and consumption need of your customers, do you think that tomorrow they will all want a conditioner and electric cooking stove? How are you going to solve those kind of problems? Are you going to design your system in a way that it will be scalable? Let me say today, yes, you are starting with ordinary, for a whole village, you are starting with ordinary 5 kVA system. For this 5 kVA system, in case somebody says, no, I have bought air conditioner and I have my money, I am willing to pay, you must give me power supply. Do you have a way to say, okay, let us increase our supply capability to maybe 10 kVA or 15 kVA? That's a question of scalability. Can you scale up your system? All these things are design considerations you have to make when it comes to economic and social, because when you are telling your customer, no, this is mini grid, you can only use 3 watts energy saving bulb. You cannot, the customer may be pissed off. And the more the number of customers in your mini grid are pissed off with your services and supply, the more you are opening room for other competitors to come in. Competitors may not come to build the same mini grid. Competitors can just be go and buy your generator, buy your fuel, put on, and say, I am no longer doing your contract. At most, you go for dispute resolution, go to court or arbitration. So apart from economics and safety considerations, the next consideration that is very important is the functionality. Yes, after meeting all the economic criteria, the next thing, Nigerians will always ask you, is it working? Is it bringing lights? That's like a popular something. So if, as you are making the choice of your OEMs, like the kind of equipment you want to use, the next thing will be like the core electrical features or the core mechanical features. For example, when it comes to solar panel, if there's a little wind, will the wind blow off all the solar panels? If there is, let me say, a little stone dropping on the solar panels, will the glass crack? I don't know. These things are what you have to check as a design engineer, like from their data sheets. What are the mechanical properties listed? What are the electrical properties listed? Can these equipment withstand harsh weather condition? What is the IP65 rating? And truth be told, some of these things I'm mentioning are not what you will just pick maybe in one day, but they come with time as you spend time in the industry, trying to read up the data sheets, following the trends in the market, seeing the features that are on, and so on. So when it comes to functionality, maybe I'll just have to say that the core job of the mini grid design engineers will just be like to continuously study the technical data sheets of commercially available equipment. So like I said, you must not say it is Victron. You can choose other things, grow what? You can choose other things, whether China or India or anything, but you must have to know like, yes, this is what the manufacturer say it can do. This is what some other people that have used these products, this is their experience. So these things will enable you, anytime you want to make design, you will now say, okay, I want to use first inverter, whether any other person has used first inverter or not. You have to keep comparing their features with specifications in standard book. For example, we know that in standard books, let me say, as the voltage is increasing, the insulation has to withstand the corresponding voltage. So if they're telling you that, yes, in this equipment, you can string your solar panels in such a way that you can get up to 1000 volts, you should start looking for features in that inverter that will withstand up to 1000 volts. If it is, if you are like for an inverter or any other thing, you can be paying attention to, okay, what is the short circuit current rating? How many kilopascals can it withstand? Does it have circuit breakers? Or do I have to spend extra money buying additional circuit breakers? Okay, some inverter features, some inverters have features such that you don't need to bring in extra changeover switches, like it will just start your generator, give signal. So do you have to leave such an inverter to go and buy inverter that after purchasing the inverter, you will spend another money buying changeover switches? They are all choices you have to make, and none is wrong. You are you being the designer is just the person that will focus, okay, to say, this is my design objective, these are my customers, these are my financiers, this is my environment, these are all the stakeholders I need to satisfy, including the regulatory agencies. So another job for things that the mini grid designers have to be doing constantly is to follow the industry news on technological advancement. At some point, most of the inverters in the market are transformer based, but today you will see many of them transformerless. They have ferrite cores, but of course they are not. Let me say the external electrical lines, distribution lines are not galvanically isolated from the inverter. So you know that, and you know what it means as an engineer designing mini grid. So you will now decide, do I have to go for inverter that comes with transformer? Is that important for me to isolate? Or do I want the transformerless one that is not isolated? These things are just decisions you have to make. And as you follow the industry news, to know technological advancement and operation success, you are having the confidence at any particular point in time. Okay, if I meet people that can, people that have less money, I can use transformerless. If I want to achieve this level of safety, I can use transformer. Do you need RCCB, or you just need ordinary MCB breakers? Is your choice. But as you follow the industry news on technological advancement and operation sources, you are having information to make these decisions. So you also have to constantly, if you are in the industry and you're a mini grid designer, you also have to constantly be comparing features and performance, as well as price of various inverters. Believe you me, it's a very difficult thing for you to do when you want to design. You will now sit down and start comparing prices of maybe many solar panels, inverters, and so on. If you already know this, the moment you want to design, your design will be faster because you will be designing from recent already known knowledge. So lastly, you also have to be following the environmental and socio-political security needs of the geographic locations that you often design for. For example, I've mentioned about Warri because I've walked around that area. I know you have to pay matching grant fee. And I know that, let me say, if you don't pay them, they will just come and carry those equipment. I also know it's not only peculiar to Warri. I've worked in some parts of Lagos where if you install something, just install and go home, come back the next day and see if you will still meet those things there. I've also seen those things in some part of Lagos. And in fact, almost everywhere in Nigeria, if you check very well, you will see that, let me say, most of the solar street lights we used to have before, their major problem is battery theft. So if you are already aware of the environment, while designing something like that, you will think, okay, how do I protect my batteries? So while designing your mini grid, if you are going to use batteries, you will also decide, okay, there's a possibility of battery theft. What do I do? What engineering design can help us secure this battery? Because if you install battery today and they steal it in the night, believe you me, the whole project is now a flop. So this is what data sheets often look like. And this is almost like the Holy Bible, Holy Quran of every designer, because you have to keep studying for various products so that on your fingertips, you will always like close your eyes and know which product to select. I am not recommending GrowWatt to anybody. I just picked a data sheet just for the purpose of illustration. So this is just in this GrowWatt, they are trying to say their various products and their capacity. So if you watch, you will see that in the first instance up here, you will see battery voltage and battery type. So they are telling you that in their battery type, you can use both lithium and lead acid. So all you need to do is it the same thing in Victron? Is it the same thing in Sucam? Is it the same thing in ABB inverters, Schneider? Is it the same thing in any inverter that comes to your mind, whether it is China or it is not China? You have to check this. At most, you request for their test certificate and warranty. Then, okay, from your electrical calculations, have you decided that your battery string is going to be 48 volts? If you have decided yes, then this is a good product for you. If you have decided that your battery string is going to be about 96 volts or even 200 or 500 volts, this is not a product for you. You still have to check other data sheets. So at least if you're going to design for a system that will use 200 volts battery, at this point, once you see that this product is having 48 volts, you just drop it. That ends it for this product. You go to the next till you see products that will meet what you want in this criteria. Once it meets this criteria, you move to the next one, inverter outputs. If you want like 20 kilowatts, this cannot really serve you unless you are going to, let me say, scale them, put them in parallel for you to achieve the capacity you want. If that's what you intend doing, fine. For example, if you want to design a 50 kilowatt system and you know that your financier may not want to bring out the money all at once, let me say the community you are designing for, their load capacity is not even up to 15 kilowatts, but you know that there's a possibility of load growth in the future. You can start with 12 kilowatts. You can start with 10. You see that in this case, this product may be one of these products, SPF 10 KT, may be a very good option for you because it's 10 kilowatts. So you can easily scale 10, 20, 30, 40, 50. Let me see, as your load grows in the future. When you look at it, okay, this product is going to combine inverter solar charger, that's your MPPT, AC input. So am I going to buy separate MPPTs? One of those things are about, like, let me say Victron. If it's Victron of the same capacity, you are definitely going to buy MPPT differently from the inverter. So do you want to do that? It's your choice. One is actually costlier than the other. So this also, when it comes to like mechanical specifications, the manufacturers, what are they telling you? Already they are telling you this is the weight of the products. So if you are going to use, let me say, if you are deciding to, okay, I'm going to mount this inverter on the wall. If you are going to use, let me say, 1-inch screws for SPF 4 KT inverter of grow watts, it may not actually work for the SKTF SPF 12 KT. That's this one. It may not actually work for the one that has 75 kg. You have to do your appropriate mechanical sizing for mounting it. Then, do you want to keep the 75 kg on the floor? You know, but just going through the specifications, you will be able to make your adequate decisions for functionality, because everything has to work. So the dimension, what space do you need? This is the size, the dimension. You don't have to finish designing. Let me say it's going to be in this cubicle, and by the time the inverter arrives, you'll be like, oh my God, I didn't know it will not size. You have already flopped. Mechanical specifications and protection degree, it is IP20. You can check ingress progression if it's your first time of hearing about ingress progression. So it's just saying that if you keep this thing in a moist environment, what it will be humid, like rain will penetrate. In fact, everything will penetrate. So what is the adequate IP value for equipment that will be outside? That this is IP20 simply means that, oh, my dear designer, this equipment cannot stay outside. For anything, you must protect it. So when you look at AC voltage, is it going to match? For example, Nigeria uses 220. Does this match? Then you know that this is an option. If it's not an option, you leave it. So these are the kind of decisions you will need to make to select your equipment. And by the time you have selected your equipment, you will now be like, okay, whether it is a popular brand or not, what is the cost? Because after your equipment have met your technical criteria, meaning that it is now safe, you can now say, okay, what is the cost? At least this will help you to get on the minimal cost of something that will work. So this particular specific data sheet can be found in this link. And there are other resources that will help you as an engineer to make decisions. You can just watch installation videos. How easy is it to install? You don't have to, when there is something that, let me say, 2 people can just carry, hold it, and maybe, let me say the other person will just screw it in, maybe 3 people. You don't have to choose an option that will require you to bring a crane. If it is in a hilly area where crane cannot come, what will you do? So before you even make a choice, you also have to check, okay, what's the installation like? What's the configuration like? Is it something that you and your team can do? Will you require another expert to help you? That expert, can that expert do it remotely? You can imagine selecting, let me say, inverter or charge controller or whatever device that will now make, like after installation, you will now have to import somebody from abroad to come and configure it for you. Manuals. When you read manuals, you have like that confidence, yes, okay, I have a very fine knowledge about this. And then product certifications. Product certifications are more like the thing you use to hold that company accountable. For example, if Victron says that in case of overcurrent, our inverter is going to trip within 2 milliseconds, it has to be in their product certifications. They have to write it down in their test specifications. So as you are reading all these things, you make decision, yes, this is a good product for me, or no, this is not. I will go for other ones. So the areas you have to pay very, very big attention when it comes to functionality is in your solar panels. So just as you have spec, as I showed you spec sheet for an inverter, there are also spec sheets for solar panels. So you basically need to say, okay, what are the solar panel brands available to me in my local market, or the ones you can import if you want to import. So where are their spec sheets? Jinko, Canadian Solar, JA Solar in Nigeria. Let's not forget, we also manufacture solar panels locally. Ozano, I can remember Ozano Solar very well. They also have their spec sheets. I can't remember more people that are manufacturing solar panels in Nigeria, but then the most important thing is when you say what's in the market, made in Nigerian products, not made in Nigeria products, you look at the spec sheet, you compare them, you can ask, okay, give me your product certifications, your test reports, and so on. You look at them, you keep them, then you make your decisions. So likewise, the same thing goes to batteries. Do you want lead acid or lithium ion batteries? You should get that. You should get information to make this decision from the industry news and success stories. You should also get those kind of information from their data sheets. What energy density do you want? What's your budget for batteries? Whatever it is will make you make selection on the batteries. Do you want to use generator? Which generator do you want? Switches and protective devices, mounting structures, and other balance of systems. You have to, like, even if you didn't get to know all of them or many products at a time, as you go on, you'll be able to, let me say, know more and more about many other products in the markets. So the last consideration there is aesthetic considerations. I know sometimes it will be as if beauty doesn't matter in engineering, but it matters. Today, let me say a little deviation. When you bring a Mercedes of 2020, 2022, 2021, let me say aesthetically, people will tell you like they are finer than the ones of, should I say 1999? Or should I say 1990? Aesthetics lures people. As a matter of fact, when it comes to engineering, aesthetics is a very important aspect. Even though we can say, yes, is a last consideration, but then the first impression people will have is that aesthetics. Oh, I like the way these mini grid lines, your distribution line, they are just so straight. People will look at it, somebody that did this, the engineer that designed this, implemented this, they are top notch. And funny enough, even if they are functional, they are economically viable, they are safe, the first thing auditors will notice when they come in is that aesthetics. They will tell you the lines are going zigzag. They will notice it. The lines are sagging. They will notice it. Are there cables that you couldn't use cable ties to clip? They will notice it. And even if it is within standard, they will still feel like it's not standard till they check the standard specifications specified by the designers. So aesthetics, aesthetics, aesthetics. The aesthetics starts by the design engineer planning for the aesthetics. Are you going to use trunk bus? Are you going to use cable trays? In the equipment yard, are you going to use gravel? Are you planning for storm water? Like that's rainwater after it rains. Is it going to be stagnant there? You plan all these things as you are designing.
Yeah, sorry.
Yes.
I don't know how long how many minutes. Maybe you can just, I don't know. How many more minutes do you want? You need?
I think between 5 to 10 more minutes, I'll finish everything.
Okay, 10 minutes. Okay, good. Continue, please. Yeah, thank you.
So in aesthetics, you think of your colors, your shape. When it comes to colors, some standards are specified by, depending, for example, if you're taking things like masks, things like MTM masks, they often have colors and they have like guide for those colors depending on the industry where you are. So when it comes to your own industry, which is mini grid, is there anything said about color? If there's none, then you can choose something that is fine. Shape of the materials, choice of materials. Are you going to use stainless steel, concrete, wooden? Apart, if it is not impacting on your cost, it's a choice you have to make. Spatial orientation, symmetry. So there are many grid design software tools. Some of them are meant to help you draft. Some of them are meant to help design, simulate, and so on. So, but then if you are going to make choice of software tools, you have to pay attention to the software features. Is it easy to learn and use? Compatibility with other softwares. How much are you going to be paying for the softwares? Security and reliability of the softwares. Is it going to crash after you've done a lot of work with it? You have to take your time, review the software tools if you're going to adopt one. Then some of the common softwares include Microsoft Excel, Homa, Helioscope, PVSys, Unirac, Typhoon, MATLAB, DigiSilence, AutoCAD, Microsoft Visio. You can use many things, many softwares to design your solar PV mini grid. But then some of them can give you a quick guide, especially when you are not yet ready to do detailed design. Example of them include softwares like Homa, Helioscope, PVCs. They can easily like tell you, okay, in these geographical locations, you want to go and do this design and installation. This is like the solar PV in radiance. Maybe give you a guide to your solar PV designs, the cost, and everything. And most often, these are for high-level design. For example, if you're going to make a quote, you may not need to sit down to design for every bolt and nut, but these softwares may not give you details of every bolt and nut. You may have to, after using this software, come back, look at the designs, and then sit down again as a design engineer, plan for every nitty-gritty. So, and that's take us to detailed technical design. Those ones may not give you everything. So in fact, the truth is that you may not get everything you want in one software. That's why we, in companies, we use different softwares because they all have technological limitations. So for you to say that you have finished designing a mini grid, the detailed technical design, you should be coming out with construction drawings saying exactly how many meters, like the normal way we have our construction drawings, bill of engineering measurements, quality specification documents, operation procedures, and so on. When you have all these things written, then you can now say, yes, you have done everything about technical design to the details. And most often, these things doesn't come, we don't do the detailed technical design during bidding. It's after you are sure you are going to do this work that you are not going to do all these things. And that's where the Homa, PVCs, and so on, that's where they come in, because they are more like a high-level design. They are not paying attention to the very little things, yeah. So, so the key areas you have to consider when you are doing the detailed technical designs include the PV array configurations. This is where you decide how many solar panels that will be in series and parallel, the racking system, how you are going to arrange them, the layouts, the power converter designs, how you are going to keep them, and how you are going to do your interconnections, your cable selections, equipment yard, how is it going to look like, you draw it out, your distribution lines, how are you going to align them, like you make all these decisions, how many meters away from the main road, from the drainage, and as you are making these decisions, remember you are referring to the standard books, the protection schemes and load management schemes. So I know that Chima is going to mention something about Homa, but then as one of those software tools you can use to do your high-level design, Homa is among them. And quick start beta for Homa is just like let me say at the moment free to use. You can just go here and explore it out. So thank you, that's all.
Wow, thank you so much, Engineer Daberici, David Agwo. Thank you for that and very interesting overview of mini-grid design. I'm tempted to say, ask if we have questions, but because we have other things to do, maybe we'll take the whole question at the end. Thank you once again, Engineer Daberici. I'm going to be sharing the PDF with us on the WhatsApp group and after the class. So that is all you need to know about mini-grid design. So in the course of this, thank you, Erese. You hear mention of some softwares that are prevalent, that are commonplace in the solar PV design. PV6, we've done that already. Another one he mentioned, which he even closed with, is the Homa software. So our next resource person is Engineer Chima. Engineer Chima, I've known Engineer Chima for the past 6 years, and he has come at least twice to come and give us presentation in NSC. I think he has written a couple of papers for NIEEE. He told me to keep his profile low, but that is much I can say, and let me respect that. So Engineer Chima is going to take us through the overview of the Homa software. It's just an overview just to bring you to speed what you can use to make your work easy. So it's not going to be like training or going to train you on software, on Homa software. But probably in the future, or maybe from next year, I will organize a session where him and some other persons will just come and focus on software design. Probably by then, most of us must have gotten into the mini-grid system or the solar home system as consultants. So that is where I believe that training will be handy. But for now, we are still trying to gather those basics, those theories, those things that I know that will serve as a baseline for a couple of us. So the next person that is going to take us now is Engineer Chimobi Nna. He's also a registered engineer, a member of NIEEE, a member of many different organizations. He has won several awards, but I'd like him to just give us an overview as a Homa specialist in Nigeria, and let him tell us what we can do with Homa. Engineer Chima, I think I've done justice to keeping your profile low, and so you also do me a favor by coming on board now. Thank you so much.
Thank you, Engineer Uche. Of course, if you announce to the whole class that I asked to keep a profile low, then that defeats the purpose. but thank you anyways. I think from my own end, I would first of all like to say thank you to Engineer Daberici. I think he has mentioned almost everything. I think at some point I just felt there's even no need for me to even do this, right? I think in the end, all the things he mentioned are very critical, and they are the things that have also held back the sector, or not held back, but have not allowed the sector to progress as fast as we would have loved it to in Nigeria. So for me, I think that his presentation was really rich very insightful, and I mean, glad to be a participant as part of this. I think I'm just somebody with the mic now, so I will just try to say good morning to everyone and hope you've been enjoying your training. Thanks you for having me here. I would just, I have a little technical issue, but I will just quickly present to you my thoughts around the software. I know we have to close by 12. I know there are 2 more facilitators, so I will just make this as brief as possible. Let me see if I can share my screen very quickly. Can you see my screen?
Yes.
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 Awesome. Okay, great. I think this is the first thing I'll just talk about very quickly. So one, I would make this presentation from a point of view of the current happenings within the mini-grid sector in Nigeria. So what we see mostly now is we see a lot of oversized mini-grids, meaning that you have 100 kilowatt mini-grid, for example, in a community, and in the end, what the community is using or really needs to use is about 20, 25, 30, 40. And what this means is that the sizing has not been done properly. And of course, if you go back to Engineer Dabreti's presentation, he spoke about so many things. He spoke about, for example, the willingness and ability for the people in the community to pay. He also spoke about your choice of equipment, so from technology to brand, and try to explain to you how each of these decisions can also affect the eventual least cost of energy and the tariff. So for me, I would say one thing that is very critical is sizing. And I know that most of you will have something that you use to size in your various organizations. So for me, this is just a simple tool I can share to Engineer Uche after the session to just share with you. And basically what we use this to do is just to do more or less, I would call it a precision load demand, right? We want our load demand to be as close as possible to what we really need to do. So for example, if you see this sheet here, this is for, let's say, a household, a typical household, for example, with a lighting point, for example, right? And this is, for example, let's say a small TV, or let's say a radio. Let's say that's all this house intends to power, for example. We then need to determine at what point in the day, and as an estimate, right? It shouldn't always be the same thing. Well, at what point in the day would these people really require to use these appliances? So for one of customer I met in one of the mini-grid sites, and then the customer says, "Oh, I go to the farm in the morning, and when I come back in the evening, I don't require so much of lighting to do anything again because I just want to eat, cook, and sleep." And so the question is, if we have provided for lighting, and in our design, we have provided for 12 hours of lighting in a day, is that, or in the 24 hours, for example, is that really what the customer wants? So the idea with this is just to have some kind of precision load demand. Now you can argue, I've heard people say, "Oh, you don't have to do that, just go to the community, ask them what they want." "Oh, they said I want light, TV, radio, refrigerator." And you say, okay, each house would be about 1.5 kilowatt, and then you multiply by the number of houses, and then you have a large mini grid that is underutilized. Okay, so the idea behind this tool is to have some level of precision load demand. So I've put 20 watts, for example, in the hours between 4 and 5, 5 and 6, and maybe put 20 watts again within the hours of, let's say, 7 and 8, 8 and 9. Most people in the villages go to bed early. They're not like city people who like to stay up at night doing stuff. They go to bed early, so they wake up early and go to the farms. So I'm just assuming that this household will require lighting for 4 hours in 24 hours. What they require, right? This is different from the World Bank definition of what is tier 1, tier 2, tier 3, tier 4, and all of level 1 or whatever of energy access. This is what the community needs in reality, right? So again, precision load demand is important. So for TV, for the same thing. So once you do all this on the right-hand side, you see the energy already, the power in watts multiplied by the time of use, and you see the energy in watt hour here. I'm going to randomize this so that we don't waste our time. So I can make this 80, assume that we watch TV towards the evening, for example, and someone needs their radios to be on throughout, maybe evening also. Let's say 10 watts, for example, right? So what I've done here, for example, is precision, right? So here I have the energy in watt hour, and this is 360 watt hour, and then of course here, what I've done here is for one household. What we see on the chart here is just showing us what is happening, what appliance is on at what time. And here we can decide that, let's say in this community, there are, for example, 80 households. And once we do it automatically, it's multiplied and we see the energy requirements for all the 80 households within that community, right? And demand factor, for example, if we say this community requires a certain amount of power or energy, what is the likelihood that they will require it all the time? That would be 1. What is the likelihood that they will never require it? That would be 0. And so sometimes a safe limit could be somewhere around 0.65, 0.6, 0.7, but whatever it is. And once we do that, what we then have is a realistic total demand, right? So from 28.8, we have 17.28. Okay, this is just for the households, for example. Now you say, oh, what of the utilities, the street lights, the churches, blah, 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 blah. Okay, awesome. So you go to the next sheet where you have table consumption. And then here you can then decide to then put in your street lights. For example, there's a church. Well, let me just say there's a religious building. Let's say there's a school. Let's say there's a community hall. Okay. And then this total demand, for example, is what you copy from this sheet here, right? This here, from here. You have this and put it into your into this other sheet, and then you just okay. All right, so let's assume that the street lights will be on. This is 9 kilowatts. Let's assume that the street lights will be on at a certain time, and I'm going to assume that all the street lights in total would give us, say, 2 kilowatts. I'm just assuming. It's an assumption, please. Okay. And then we can also decide at what time they will come on, right? So I'm going to put it on up until 5 in the morning when they are on their way to the farm, and it's off for the rest of the day. Religious building, for example, the lights are depending if it's a church or a mosque. You can also walk around the frequency. It's not every day, so you can divide by the day and determine what the requirement in kilowatts will be for a certain day. Same thing for the school, same thing for the community halls. And once you're done with that, here you then have a profile. You refresh and you have a profile that gives you an idea of what the entire community requires. So you are taking care of the households from this sheet. You're taking care of the other utilities from this sheet. And the idea is to be as specific as possible, right? Coincidentally, we have several energy auditors within this training today. So they can also very much tell you why it is very important to, as much as possible, be specific when it comes to energy load, demand projections, and the rest of that. Okay, so once you do this, then you jump into the Homa software. So I will just share another screen again. I hope I'm able to share this. Let me just close some of the sheets. Please just give me a minute. I need to share certain slides. Okay, can you see my screen?
Yes, sir.
Yes.
All right,
Yes.
awesome. Okay,
Yes.
so I'm going to rush through this. Don't forget that the Homa software, right, or for any software you can ever think about, it's always garbage in, garbage out, right? So it means that if you put in unrealistic values, if you put in if your input is not accurate, what the software or the simulation tool does is to process your garbage and bring out processed garbage or fine garbage, right? So your results will still not be what you want. So the idea is that, again, I'm going to reference Dabrichi's presentation because I think it was very, very insightful, that you have to, as an engineer, design engineer, make certain strict but flexible choices based on certain considerations. And this is what informs your input into the tool. So the tool does not necessarily start to think for you or try to refine what you need to do. So basically, like I said before, the input is as important as even the tool itself. So it's important to have very good inputs. Don't forget that if your inputs are not good, what you get is oversized results. I've mentioned this already with the current situation within the mini-grid space. We are seeing, or we've seen in the past, of course, things are changing. We're having better designs. But we have seen in the past really oversized results. And in some cases, we have seen very unrealistic results. Again, I hope that engineer Dabrichi's session was recorded so that people can go back to listen to that. I think I will listen to it myself because it's really good. Unrealistic results, for example, you have to take care of this. Criteria and convergence, for example, does your software give very feasible solutions? Very important. Now, what Homa does, or what these softwares do, is to simulate different sizes and possible combinations, right? So it's not a one size fits all. So you see several results and you have to pick the results that fit most to your own consideration. I don't want to go through this. This is more like a project management discussion. And of course, we should know all of this in terms of dimensioning, sizing, the configurations. Okay, now here we are. This is what you have eventually when you are done with your simulation. What you have is a list of results, of solutions, right? If you look at the first line, for example, we are using a 21. Okay, let me start with this side of the screen. Here we have more like a framework. What would I use? Probably the right word for your entire design. This is your load here, right here. This is PV. This is wind. This is your generator. This is your battery. And this is your converter, so inverter, as you may choose to call it. Now, the idea is that our load is most likely an AC. This should be this like DC directly. And we have the PV, we have the wind and the generator. And the idea is that this load is connected to an AC bus bar, right? And we have to find a way to ensure that everything that we connect into that bus bar that feeds the load is AC. So whatever DC inputs coming in have to be inverted or converted, as it were. In the solar simulation, you also know that you cannot operate a PV system without the corresponding resource. So for example, if you put solar panels out there, it's not the wind that creates the photons, for example, that fall on the PV and generate your DC current is the solar resource. So for everything you see here, right, you see the corresponding resource that is required to power it. So for example, you have the PV, here you have solar resource, you have a wind turbine, here you have wind resource, you have a generator, here you have diesel. And here are the other considerations, the economics, the system control. Do you want it on at a certain time, off at a certain time? The economics, what is your interest rate? What is the capital investment if you invested in the project? What is your, also all the values you need, basically. Grid extension, for example, this is really important. Does it make sense to put a solar PV in a certain location, or does it make sense to extend the grid, right? So once you choose this option helps you to tell you the distance at which it makes sense to extend the grid and the distance at which it makes sense to go and install a mini grid in the community. Here we have the emissions and here we have the constraints. So basically, this is what you see at the point when you have all the feasible solutions from Homa, right? This is what you have imputed. In each of these icons, there are several parameters you have to put in place. Again, back to Dabrichi's presentation, the cost of the battery, the type of battery, the voltage of the battery. Do you want batteries that are 2 volts, 1,800 ampere hour? Do you want what do you want, basically? So in these icons, you go choose what you want. Don't forget, depending on what is available in the market, depending on the technical specifications, depending on the technical sheet. So there are many things you have to consider to be able to come and impute into Homa. So Homa is not the guy that you just put in anything and you get fantastic results. No. Homa is the guy that allows you to think very well about your design, and put in all the right inputs. And then what it does for you is to give you the best possible outputs. And then you can choose from there. So in this case, for example, we have 48 simulations that have happened already, for example, and we have some of these results. In these results that Homa has chosen, for example, the first one, we have 21 kilowatt PV. That's what Homa is suggesting to you. Here, Homa is suggesting to you three wind turbines. Now, the rating or capacity of these wind turbines would be somewhere, when you click on this, it will be somewhere inside that, that icon, all the specifications. But here is a summary. 21 kilowatt PV, 3 wind turbines, 36 kilowatt generator, 48 H1500 batteries. Now we don't know the exact specifications, but it has been put into this icon before the simulation has happened. 15 kilowatt converter. Now this is your initial capital cost, $162,437. This is your operating cost, 2322. This is your NPC. This is your LCOE, least cost of energy. So this is your tariff basically. It's saying for this solution, the tariff would be $0.603 per kilowatt hour. In this solution, your renewable energy fraction, don't forget we have diesel here, right? It's 83%. Here is your capacity shortage. Here is the liters of diesel you will use in a year, right? And here is the number of generator hours, for example. So this is just one solution, right? This row is one solution. This is another solution here. Here is saying 30 kilowatt PV, 3 wind turbines, blah, blah, blah. And here at the bottom, it says 50 kilowatt PV, right? 1 wind turbine and the rest of it. Now, what Homa does is to arrange all your solutions from the least cost to the highest. So this is 0.603, and here at the bottom, we have 0.653, right? So basically, you are always tempted to go and pick the first one because it's the cheapest, right? But it always doesn't work that way. Don't forget, this is a list of feasible solutions. It may turn out that while this is the cheapest, you don't have, what do I use? While this is cheapest, for example, you have a lot of space, ground space to put your PV, and maybe the wind speed in this certain area is too poor, right? Or I mean, for several reasons, we didn't, cost, availability, resource, or whatever can make you go from the least cost to somewhere here, for example, right? Depending on what happens. But this is what Homa does for you to say, look, all things being equal, based on all your inputs, this is the combination that Homa thinks will give you the least cost of energy. But it will not always be what will happen on site, rather, in reality, right? So based on your situation on site, availability of equipment, cost, resource, you could then decide to go and make pick some other solutions that are not necessarily the least cost. Of course, cost will always be the first, or one of the first considerations, but it will not always be the only consideration. So that this is basically what happens. Like I said, we can't do this. I mean, Homa trading is a 3 days training. So I'm just going to brush through the results to just see what it looks like. Here, if you double click on this, on any of the solutions here, Homa then gives you a deep dive into what you have clicked. So here, for example, we have a deep dive of our system. And here we see the PV, the cost, net present cost of the PV. This is this should be the wind. This is the generator, I think. This should likely be the battery. I can't see the color codes too well. And this is the converter. So this is what Homa has given you, like a cash flow summary, right? So this way that's shown you which of your, so in this case, battery has the highest cost component, right? It's clear, you can see it from a glance, okay? So this is how Homa does it. And then you see all of these icons: cost summary, cash flow, electrical, PV, this is the wind turbine, this is generator, battery. Once you click on any of these icons, it gives you a more detailed analysis of your system, right? And don't forget that this is something you have to sit down to do as a design engineer. You have to look at the results very clearly before you then start to produce a report to top management before the decision is made. So you always have to check very well if everything you see in the solution you have picked reflects the reality on ground, reflects the direction of the organization, reflects what the community needs, reflects what the grant you intend to assess needs, reflects what the investor requires, and all of these things. Here on this sheet here, what Homa tells us is also how much we will spend initially, right? This is our year zero, right? Our capital, basically. And here, Homa gives us also all of our operation and maintenance costs. And as you see here, and Homa shows us the parts where we need to reinvest, make a purchase. Usually, this could be maybe at the point of the inverter or maybe even the battery, or whatever it is. But at this point, Homa shows you, based on the life cycle they have put into the software, Homa shows you at what point you need to make a replacement, at what point you need to do operation and maintenance, at what point does the project end. So for example, the project ends at year 20, and Homa is showing you also your salvage value, right? Salvage value will mean that if you want to dispose of all the equipment in the mini grid, that this is how much it would likely cost. This is not always real, but this is what it would likely cost. So basically, this is just a quick summary. I think I will stop here because there are other facilitators, but basically the idea is that Homa is a fantastic tool, right? And you, as a design engineer, have to pay close attention to what you put into the software. Now, how did we get all of these resources? For example, if you go into the Homa software, Homa will prompt you to put the exact location of your site, right? And once you put in the exact location of your site, the latitude, longitude, once you put in the exact location, Homa has access to certain resources from NREL, from NASA, and it then populates all the solar resource and the wind resources automatically. So there are two ways to go about it. If you want to be the design engineer that wants to get the on-ground information and you want to carry out the 1-year assessment of the resources in your site, interesting. If your company is not necessarily bothered about executing a project, this makes sense. But of course, this is not the reality, right? The reality is that you want to have your projects kick off as quickly as possible. So you have tools that are integrated into the Homa software that provide you some certain information from NASA, from NREL, that allow you to do this. One other thing I need to mention, the prices, right, that you put into the Homa software, is important that you do very good market survey. Back to what Dabrichi said, he said it's important that you follow the market trends. You know what these things cost, you know the inflation, you know how everything is going in the market, so that when you design, you can easily just put in all these values, right? That's one thing. The second thing that he mentioned, matching ground fee, omonile, when we're the Goshians, omonile, matching ground fee, fee for this, fee for that. All of those things would have to be factored in somehow into the simulation, because in the end, your tariff is a function of every single thing that happened on site and costs you money, right? But Homa was not built in anticipation that in Nigeria there is matching ground fee, right? So you have to find a way to make sure that all of these fees are captured somewhere within the software, right? Again, this is not the platform to explain these things in details, but I just want to just point these things out to you, that it's important you take them into consideration. So I think for here, I will stop here, because the Homa software training is not something that can be done in 30 minutes, right? It's 3 minutes. This is an intro. These are pros and cons. I'm going to work on the cons. For example, quality input is needed. Detailed input is needed. Experience criteria is needed. If you miss key values or sizes, Homa will not guess them, right? So anything that you miss, you do not put into the software, Homa will not guess it. You have to put everything you know and as accurately as possible into the software. And the last one says you cannot lose yourself. You can lose yourself if you don't set the adequate questions. So for example, why this mini grid, this community, what is the purpose, what is the objective? Dabrichi has mentioned everything already. And to be honest, I would encourage everyone to, if possible, go back and listen to Dabrichi's session again. Because like I mentioned, I almost do not feel the need to have this session anymore, because I think he hit the nail on the head by pointing out the very, very critical things that are needed if you need to design a very effective mini-grid design. So I'll stop here and thank you again for having me as a participant on your training. Thank you.
Thank you so much, Engineer Chimobi. Thank you for sharing your experience with us. And as you said, we're going to take it off from there. One thing I often reassure participants in all our training is that most of this training is not that you suddenly become an expert, but the training will expose you to what you should know, as for instance, as a mini-grid developer, or as a renewable energy expert. So actually what Chima said is right. The third resource person just informed me that the two previous speakers have said virtually everything she needed to say. She is also in the mini-grid sector, and we'll stop here for today. Probably in the next cohort, I would like her to come in, and Engineer Dabrichi will still come in again. And me and Engineer Chima were discussing that it will be good for every participant to be given an opportunity, maybe after a couple of months, to come back and maybe participate in the energy auditing session of this training, so that we know that, yes, that justice have been done to the whole energy management sector. So thank you, Engineer Chima. Thank you, every participant. Now is question and answer time. Now, we've spent our time together in the last 5 weeks, and I believe that much value has been added. I have sent out a list to get our feedback so that we can improve on this training, as well as capture your name and use it for our certificates. So if peradventure you have not filled that form, I'll repost it again on our WhatsApp group, and you can fill it, and within the week, I'll be sending your certificates to you. So at this point, I would like to entertain questions. The resource persons are here, and we have like 20 minutes to do that.
Yeah, I have a question.
Okay.
My name is
Johnson.
Okay.
I want to suggest, God judge you, yes, that the questions should be sent in the chat room so that we can maximize time.
We are done, sir. We are finished for today.
I need to put our questions in the chat group so that you pick it from an answer to save time. If each every one of us start talking, you see that the 20 minutes we have cannot give us much.
Okay, sir. Okay, we'll do that. But now let's just take few, maybe just like 5 questions. Everyone should keep it brief.
Yes,
and straight to the point.
I started asking. My name is Engineer Ogali.
Okay.
I've submitted my name and my profile so that we can send the certificate. The thing is, we have learned a lot of softwares. There's a PV system. We have also learned Homa. My question is it possible for us to know how much it costs to own those, to buy or to acquire those kind of softwares, and how long does it take? Is it 1 year? We pay for 1 year, we pay for 6 months. How does it, what does it cost? So that if we decide to on our own acquire them, what do we do? Thank you.
Okay, that's a good one. I'll answer one, and maybe Chima will answer the other one. Chimo will answer the other one. I think the PVC cost about $700, and it's for 1 year. Most of the software is for 1 year. So I think that's cost around that, no more than that. But as I said, you have this opportunity to use it for a month on the free trial. Probably when you have projects that you know is going to pay for it, you can now go for the paid trial. For the Homa, it's a Canadian software. I guess it's pretty more expensive. So Engineer Chimobi, I don't know whether I know how much it costs, but I think we can also Google this thing.
Yeah, you can Google it, but I think it's roughly, it depends on the so for example, these softwares are different packages. For example, for the student package, you can have it as low as $6 to $21 per month.
Okay.
And for the software itself, you could have it for as much as $42 per month to about $125 per month.
Oh.
But again, I mean, depending on, I would always advise that before you make any of these purchases, just figure out the extent to which you want to use it, and so that you can make a very good decision, right?
Yeah, that's a good one. Okay, thank you. Any other question, please?
Yes, can I ask my question?
Go ahead, sir.
And it's about the Homa. So my question is that, thank you for the presentation. I have 2 questions. Number one, about even the meaning. Well, I know Homa is an acronym, and sometimes I read hybrid optimization of multiple energy resources. In another paper, I will see electric renewable. So please, what is really the real meaning of this acronym?
This is a very hard question, because in 2013, when I started using Homa, it used to be called Hybrid Optimization Model for Energy Resources.
Okay.
Exactly. That's what I knew in 2013. But again, I mean, I don't work in Homa, but I think it's good to just Google and maybe read about why they've made some changes from then until now. But I know that the multiple energy resources and all of these things are new names now. But when the initial versions of Homa were called Hybrid Optimization Model for Energy Resources. But now there's been some name changes.
All right, thank you. Then number 2, in a situation whereby maybe I'm designing a hybrid of those 2 energy resources, is it economically viable to use Homa, just only 2 energy resources?
As long as it's more than one, the hybrid word already takes care of it. So yes, it's okay. And of course, it's also possible to also design with single resources. But of course, the idea behind Homa is for you to be able to combine several resources together. So once it's more than one, it's cool.
Okay, thank you.
Hello, Chiduche, can I ask my question?
Go ahead, sir. Go ahead.
Yeah, good afternoon and thank you. My question is, can we in the future consider having a kind of workshop style approach to this kind of training, whereby we do on the job or on hand practice, so that, when you make a presentation, people watch you, it might look easy, but when you want to do it on yourself, you'll be seeing a lot of challenges. But if we have, like we had a satisfaction, we can have a small one that can be, okay, take us to where their computer, where you install your bring our laptop, we install this, and then we use a session to try our hand around it. It will impact more on us to use the tools which are being discussed. Thank you.
Yeah, I think I can relate with that. More like a classroom setting. But the challenge with that, even though we'll look into it and discuss it, that will be from next year, is the issue of logistics. Just like now, many of us are logging in from all over the country, even as far as Germany. But when you do in-class training like this, it means people have to come all over the country. They have to stay in the hotel. We have to do a lot. And sometimes it can be very extensive in terms of the time and the organization. But notwithstanding, I think after the COVID thing has really gone out completely in the system, I think we'll definitely go back to classroom. But then the online thing will still go side by side, definitely. It has come to stay. So we'll look into it, sir. Thank you.
Thank you, sir.
Yeah, what's your question?
Yes, good morning all. I just want to say thank you to yourself and Engineer Chima and our resource speakers today for the well-packaged trainings. My question is this course we have had is a foundational training or foundational to becoming a certified energy auditor manager. So after this, what next? In order for those of us who still have the ambition, the aspiration of becoming an energy auditor or energy manager, what next, please?
Hello.
Hello, sir.
Hello.
Sorry again.
Please, before you answer this question, I want to add to it because it's similar to my question. Now, I noticed that most of us who are participating in this very training have 2 or 3 things in mind. One, people who wants to actually open up a shop and sell PV materials. People wants to be a consultant, and people who wants to maybe take exams and become a consultant at the long run. Now, I wanted to see how you can group us and begin to see how you can meet our needs in this with your training. Do you understand? Begin to relate us side by side with respect of what we need, because it's coming down. These my students now. I've trained them to this level. I want to bring them down in spaces. I want to set up a shop to sell materials. How do I source them? How do I help this guy to kickstart? I want to be a consultant alongside with this. What do? I need to take a energy audit or energy management certification. How do I go about it? It's lifestyle. That's why I say, let me put in mind so that I can answer them wholesomely. Hello. Hello. Hello.
Okay. Thank you so much. I think let me try to others will still add something to what I'm going to say. They say that the journey of 1,000 miles begins with a step. For me, this is the first time we're organizing this training in this format. And we have a sketchy idea of what we have in mind. And that's why we've been able to build a WhatsApp group. And we've done a site visit.
Okay, I think Ichinochi is having some technical challenges. Until he comes back, let me just continue from where he stopped.
Hello, I'm back now.
Okay.
My apology today. All of you agree with me that we never had this network issue prior to now. Even starting the class today was an issue, but it's okay. This is our final day. So I think in the platform, we're going to continue the discussion. We're going to discuss what we do from here. Last time we tried to share information. So some of these materials will be shared. And just one of our participants came to my office and we had a good chat. And from that chat, he changed my perspective about the mini grid being done by REA. And my perspective have changed, courtesy of Engineer Obinago. Okay. He told me about the NEP, the World Bank grant, performance grant stuff. This is things I know I just overlook. But I was able to see that, look, this thing is working. In as much as the sector is still getting to maturity, right? Me and Grachima discussed this yesterday, and I told him what the Germans did. And I think that's what the federal government is trying to do. Everybody who comes into the mini grid thing, come into the solar thing, and then government gives you those grants, gives you those incentives, and then when government will not start withdrawing gradually. So by then, all of us are already...
Sorry to cut it. I think it's better you stop the recording.
Okay, I think he's still recording. He's recording, sir.
Yeah, but I'm thinking that is it not better we stop the recording now?
Okay, yeah. Okay, it stopped.